Hello, I'm Professor Michael Kaye, and I'm going to talk to you today about the standard normal distribution. I'm going to show you how you can find the probability that the random variable is less than a value, greater than a value, or in between two values whenever we have a standard normal distribution. So for example, I'm talking to you about a problem that might look like this. Let's say we were asked to find the probability that z is less than 1.62. So the first thing I'm going to do is draw my standard bell-shaped curve, and I'm going to mark 0 right in the center of the bell-shaped curve, and then locate 1.62 on my z-axis, which is right here. Now 1.62 is a positive number, so I'm going to put that a little bit to the right of the 0, maybe right about here. And since I'm looking for the probability that z is less than 1.62, I'm going to shade to the left under my bell-shaped curve. So I have a shaded region that looks like this. Now, in order to find the area that I've shaded here, which corresponds to the probability that I'm looking for, I'm going to have to get my standard normal table out, and I'm going to go to the row where I see 1.6, and then I'm going to move over to the column where the second decimal digit is a 2. And the number that I see there is 0.9474. That's the area that is to the left of 1.62, which happens to be the area that we're looking for. So the answer to our question is 0.9474. The second type of problem that I want to show you is what happens when we have the probability that z is greater than some value. So for example, something that might be like this. Let's say we were asked to find the probability that z is greater than negative 1.16. Again, the first thing I'll do is I'll draw my standard bell-shaped curve. I'll mark 0 right in the center of the bell, and let me label this as my z-axis. Now negative 1.16, negative numbers are on the left side of 0, so I'll mark this one somewhere over here. And since I'm looking for the probability that z is greater than this value, I'm going to shade to the right. So this time my shaded area is going to look like this. Now if I look up negative 1.16 in my standard normal table, the one that I showed you a few minutes ago, what I'm going to see is the number 0.1230. That number represents the area to the left of negative 1.16. So I'm actually looking up in the table this area, which is not the shaded region that I want. In order to find the amount of area that I've shaded over here, I have to start with the entire area of the curve, which is 1, and then subtract off or cut off that part that's to the left of negative 1.16. So let me subtract off the 0.1230, and when I subtract, what I have is 0.8770, and that represents the area that I've got shaded to the right of negative 1.16. The third type of problem that I want to show you today is what happens when we're asked to find the probability that z is in between two values. So for example, let's say we were asked to find the probability that z is in between 2.00 and 2.47. Again, the first thing that I'll do is I'll draw my bell-shaped curve. I'll put 0 right in the center, and then I'll mark down the two z-scores that are of interest to us, which is 2.00 and 2.47. Now, since I want z to be in between those values, I'm going to shade under the curve in between the two values that I've just marked. So my shaded region now looks like this. In order to find the area that I've shaded, I first have to look up how much area I have to the left of 2.47. So if I go to my standard normal table, if I look up 2.47, the amount of area that I've got shaded to the, or the amount of area that I have to the left of 2.47, all of this, is 0.9932. Now that 9932 includes more than just our shaded region. It also includes all of this unshaded area to the left of 2.00, which we really don't want. So let me look up how much area is not shaded there. So again, I go to my standard normal table, I look up 2.00, and the amount of area to the left of 2.00, which is not shaded, is 0.9772. So if I want to find out how much area is shaded, I'm going to start with the 0.9932 and then subtract off the 0.9772. So it'll look like this. 0.9932 minus the 0.9772. And if we do the subtraction, we should get 0.0160 for the amount of shaded area, and that becomes our answer.